I'm a developer at Outpace Systems, and we are a relatively small company. We're a distributed, fully remote company. We're all based in the US. We are a Clojure shop, so we use Clojure on our back end, and for the front end, we use ClojureScript. And our main product is what we call the targeting engine. And to explain how the targeting engine works, I need to talk a little bit about our clients. So our clients are people who have a lot of customers. I cannot say who exactly our clients are due to the confidentiality agreements, but for this particular talk, our client is a very large hospitality chain with over 4,000 properties, over 10 million or tens of millions of loyalty members. And for each one of these members, they know a lot about those members, both in terms of things that the member has told our client, like where they live, and also from the behaviors of the client. Does the client like to stay at beach resorts, or they prefer more like ski resorts or something like that? So they have all this information about their customers, and they also have a lot of offers that might be of interest to those customers. So these are going to be things like, stay 2 nights, get the 3rd night free, or earn bonus points towards the rewards program, maybe a spa credit, and we have lots of these. Like for currently active, we have over 10,000 of these for this customer or for our client. And so what the targeting engine tries to do is at a given time, they know they want to present some offers to their customer, and we help them find out what is the most relevant offers for that customer. And in some cases, we don't know anything about the customer because it's an anonymous user, in which case we just try to get them the best performing content. So we integrate into lots of different channels. We have JavaScript that we publish that is included in our client's website to inject the content directly into their website. We have a user interface that our client can use to do batch processing, for example, for an email campaign. And we also have APIs that our client can call directly for things like their mobile app and for booking abandon, which is the flow that I'll be talking about today. So booking abandon is a common pattern where you have a user that goes into a website and starts doing something, in this case, starts booking a hotel room, but for whatever reason, the user leaves. And at some point later, the client notices that there's this booking that was started, but for whatever reason was never completed. So they send us that information about that booking, the user ID and which hotel and which dates if they have that data, and we tell them, well, based on the information you've given us, your customer might be interested in these offers. At which point the client will then create an email that they send to their customer, which will hopefully result in the customer saying, oh yeah, I might be interested in this offer, and they sign up. That may or may not happen. And the problem that we have is that our targeting engine was not what was being used. We originally developed, the first iteration of our targeting engine was crafted really for this client and was not suitable to be reused as a product. And so over time, we rewrote it, and now we want to transfer this flow from using the old product to the new product, and we want to do it in such a way so that we have 0 impact on our client. No downtime, no code changes from their side. And so how do we do that? And the approach that we decided to do is treat the existing code base as like a black box. So we just want to see how the current system behaves without really going into how it actually does what it does. So things like unit tests and all that, don't really apply in this scenario. So I want to answer 5 questions. The first 2 are about the existing system. What kind of input does it get? And given those inputs, what kind of responses do you get? Once you know that, then you can look at the new system and ask, well, does this new system accept those inputs and produce outputs that are similar? And finally, even if everything is the right shape and the right type, you have to ask, well, is it actually correct? Are we getting the real result? So let's see how we can answer these 5 questions. The first step is dealing with the inputs. So the inputs in this case, we're dealing with a REST API. So it's things like the HTTP method, query parameters, headers, body. You want to kind of classify all these different inputs. What kind of values do they have? And are there any patterns in the requests that you need to be aware of or you'd like to exploit? And there's all sorts of different ways that you can get that data. You can get it from access logs. You can use like a network sniffer to get that stuff off the network. Or if all else fails, you can always just put a proxy in between the client and your old system, so that way you can see fully what's going on. Now, in our case, we're dealing with gets, so it was very simple to just pull down Nginx access logs off our servers and work with that. So we started with taking just a few days worth of access logs and using just standard command line tools like grep to kind of filter out just the requests that we're interested in replacing. And then once we load that into a file, we can use Clojure to convert those lines of log into just a map of information about the request. So like in this example here, we can ignore the path, but we take that 42 part of the path and it becomes the user ID, and then the rest of the query parameters are pretty much just pasted in. We don't do anything special yet. So at this point now we have this large collection of input data, and now we need to figure out, well, what is all this? What are all these different data types? What do they mean? And this is a part where spec starts coming in. Essentially, you start specifying, all these inputs to see, what are the types, what keys are present. You might want to consider when you're doing this to do a lot more parsing than you normally would, say, if you're specifying the input to a function. So you might not just verify that something is like a string of digits, but you might want to, parse it into an actual integer and see if it's positive or negative or whatnot. Another thing that you normally wouldn't do in a lot of normal spec usage is reject unknown keys. But in this case, since we're really trying to understand a corpus of data, we want to be sure that we're not ignoring anything. So what this kind of looks like in practice is that we have our parsed entry, and we will write a spec that will try to that when you conform that entry to that spec, you get this conformed entry. So we create kind of regular keywords for each one of these inputs, and we can even do some parsing there. So our user IDs are very, very long. So they don't fit into a long, that's why it's 42N, it's a big int. For things like num rooms and num adults, we can go further and say, well, these must be positive. Num children must be non-negative. So at this point, we should have a pretty good idea of how our API is being used. And more than that, now we have these specifications that we can use for doing things like input validation. We can take these specs and put them into our new system and say, we can use this to just validate that the input that we get is valid. If you attach generators to these specifications, now you have a way of just generating inputs for your system, and you can use that for testing. So at this point, we've answered the first question. What kind of data does how is our client calling our application or our our legacy system. So the next question is, well, given a given input, how does the output look like? And when you're doing this, you want to check not only valid inputs, which hopefully that's what you're getting most of the time, but you also want to check invalid inputs. So there's a couple of ways, again, that you can get around to collecting this data. The simplest way is to just invoke the input. You have a bunch of input data. You just invoke the old system and see what it does. In a case where this is impractical or not possible, you'll have to do something like sniffing the network or proxying the endpoint to get that data. So in our case, we could just collect all that data, and then once you have the results, it may contain things you don't care about. Like there's all sorts of headers that you may not care about. There may be there may be stuff inside the response that you don't really care about. But in either case, what you want to do is collect all the data and now, again, start specifying things. So in our example, we just invoked the endpoint, and we have the map that's returned from our HTTP client. So there's things we don't care about, like the options that were passed in with the requests we don't care about, headers we don't really care about. What we do care about is the status. If it's 200, that means that this is an OK response. If it's something else, it's some other type of response. And the body. Now, the body is just a string. As we can see, a string contains JSON. And what we actually want to end up doing is when we write the specs for our output, is we actually parse that JSON into Clojure data structures, and then we can even do more beyond that. So as we can see, the conformed result of this response is that it's an OK response, and it has some offers, and each offer just consists of a name. So at this point, we have an idea of not only the inputs to the legacy system, but also the shape of the data that comes back out of it. And again, because we've created these specs, now we have specifications that we can use. For example, we will definitely use them when we test that our new system conforms to the way the old system works. But say you were also working on a client for this particular API. Well, now you have a generator or sample data that you can use for testing your client. Now, in our case, we didn't write the client. We have nothing to do with the client, so we didn't use it for that. So the next two questions that we need to answer are now about the new system. Now that we think we have a pretty good understanding of how the old system works, we need to see if the new system works the same way. And we could tell a priori that it doesn't. We know that the new system doesn't accept certain types of input parameters. It may or may not produce the right output. So one of the tools that we decided to use is Amazon's API gateway. And the API gateway can do a lot of different things, but we're interested in it primarily for two purposes. It serves as a proxy that can do transformations of requests and responses. So that allows us to make our new system behave more like the old system without actually changing the code in the old system. And as we'll see, towards the end of this talk, we'll see how using API Gateway made deploying from the old system to the new system very easy to do. So an example of some of the rewriting that this can do is, we have an input and we want to invoke our new endpoint in a certain way. So, we tell it, okay, this is where the new system lives. You need to invoke the endpoint here. And, here's the old path, but we actually want to call, this new path. And in fact, this 42, which is part of the path in the old system, we need to turn it into a user ID. And over here, this number of offers to get, well, that's just num in the new system. So this is all really easy to do in API Gateway. An API gateway, you can also rewrite the payload of a request using a velocity template. And we considered doing this, but opted not to. And there are a couple reasons for this. The velocity templates that we'd have to write would be very verbose because like the responses are very large that we're sending back. And since this was an endpoint that was only going to be called for this one client, it was a lot easier to just change our new system to return responses that behave like the old system. But if you're in a situation where that wasn't an option, then API Gateway kind of helps you in that respect. So our new architecture is going to have, we have our targeting engine, the new version, is sitting behind the API Gateway that's doing the transformation. And now that we've set this up, we can start exercising the new system using the data and the specifications that we created before. And so if you wrote your input specifications so that you can generate inputs, you can use that. In our case, we had, tens of thousands of sample calls that we just replayed through the new system. And we're able to check that the responses that we're getting at least conformed to the specification for the output. Don't forget, of course, again, errors are a part of your API, and you need to be sure that the errors that you return also conform to the old system. So at this point, we have two systems that ostensibly behave the same way. They accept the same input, and they produce the same sort of output. But there's still the question is the output correct? Are we actually returning the data that we need that we're supposed to be? And that's the last of the 5 questions that we need to answer. So how do we do that? If your endpoint happens to be referentially transparent, then this is trivial. You just invoke both endpoints with you invoke both endpoints with the same input, and you should have identical output. But most systems are not like that. They have some sort of state or something that you need that affect the output. And fundamentally, the technique is the same. You just invoke both systems with the same input, but then when it comes to considering what the output is and is the output correct, this really depends on your particular application. Again, error conditions, don't forget about them. So in our case of booking abandon, there's 2 parts of it that were, that affected the responses. The first one is that each one of these systems maintain a database of the available offers for each property. Secondly, there's a client endpoint that we invoked to find out if particular offers are available for a given date. Additionally, there's some things that naturally varied between the old system and the new system. The algorithms, although they're doing essentially the same thing, were slightly different. So, rankings of offers might be slightly different. The calculated values that we produce might be slightly different, but that's fine. Those are still within, this is correct. And so the way I ended up doing this, which was kind of a tedious process, is, I take a sampling of input. I forget how many it was in the thousands. And I invoke both endpoints, and essentially now I have this massive data structure that contains the input and the output from each system. And what I ended up doing is just kind of looking at little bits of the output, kind of a little bit at a time, and running Clojure data diff to see, are these the same? If not, how are they different? Are they different in such a way that one of the systems is wrong, or are they different in such a way that it's okay? So some examples of how this might look like, with an exact match. Well, that's trivial. If you have a case where there's missing offers, well, why is that? Is it that the old system has offers that it shouldn't have? Or is it because the new system has offers or doesn't have those offers and it should? So this, if we run into this situation, we have to go and investigate, well, what's going on here. If something happened like, we get the same offers but in a different order, in that case, this is okay. We don't have to worry about that. In other cases, maybe we have slightly different offers. Again, this is something we have to look at, why is this the reason? Is it because that offer is missing from one of the two systems? Or is it simply because, well, there's 8 offers to choose from, and we're only picking the top 2, and each system ranks them differently. So this was a very tedious process to kind of go through and make sure all that was correct. But we did find a number of things. This was a very valuable exercise. One of the examples is that in some cases, this endpoint was invoked without dates, and there's some slight differences in how we handled that. So we fixed that. We found differences in how the two systems synced offers. We fixed that. We discovered that the old system had a bug that we had never discovered up until now, that when the client asked for like French offers, we'd give them English ones instead. Oops. So that's something that our new system fixed, and that was nice to see. So now that we had gone through this process, we had a very high degree of certainty that when we made the switch, that it should just be transparent to our client, that they didn't have to change any of their code in order to be using our new system. So now that we've answered all our questions and have developed a certainty, the last bit of this is to deploy the new system. And so we have version 1 that's running, and we have version 2 running behind the API gateway. And right now, like the DNS name that the client is using goes directly to the old system. So our first step was to add a new version of the API in the API gateway that just passes things through. So once we do that, we can check that invoking it through the API gateway and invoking it directly results in the exact same thing. Once we do that, we can switch the DNS to now go through the API gateway. Now, at this point, we're all set. The only thing that we have to worry about is just getting the OK from the client to make the switch. And when we do, it's really just like clicking a couple of buttons in the AWS console, where we just tell the API gateway, instead of running the pass-through, run through the transforming. And that was it. There's no downtime. Within minutes, all the requests are now going to the new system. And because we spent all this time verifying that the new system behaves just like the old system, there was no interruptions and no code changes for our client. And this, for us, was a big success. It took a few weeks' worth of work, and at times, creating these schemas or specs, was very tedious. But, the end result was a complete success. Essentially, we treated our old system as a black box that we knew nothing about except for what goes in and what comes out. And we were able to replace it with another system that's completely unrelated, completely different infrastructure, and we're able to do it without impacting our client at all. Well, that's not entirely true. I learned that several months later, someone was trying to manually call our API. It's normally only called through a machine, and they were calling with different parameters that we weren't expecting, and so it failed validation. But that was still a success. So some final thoughts on this is just that this was a very useful experience for us to go through. And we use Clojure spec primarily because, that's the latest, greatest thing, and we're developers, and we like the, brand new, shiny thing. But, you could still use, like, a plematic schema. It has most of the functionality that you need to be able to do the same thing. And it's really nice that after all of this, now you have artifacts that you can use in your new system for things like testing and input validation. That's a great result to have on top of having been able to do this replacement. And finally, there's room for exploring how where can you take this? Can you use this to document your endpoint in such a way that the client can better make use of that. And I know there's some efforts out there that you can take like a open API specification and turn it to a Clojure spec specification. But I wonder, is it possible to go both ways or whatnot? And that's it. Thank you very much for your time. I guess that's